Hello again, year 11. Now that we've learned all of our trig values, we're going to be able to do some maths where we are using them. But before we do that, let's just double check you have actually learnt them. So you can write numbers 1 to 10 in the back of your book, or you can just do this mentally. I'd like you to pause the video here, have a look at these quick questions and see how many of these you know. So I'm now going to go through the answers to these. You might hear me pause as we go through these because I'm going to have to think about what these values are. And I wouldn't say I can rapidly recall these like my times tables, but I normally can work them out in my head if I need to. So sine 30 is a half. Cos 90, picturing the graph, is 0. Sine of 0, again I'm picturing the graph, is 0. Now it's always tan 30 and tan 60 that I tend to get the wrong way round. But then I suddenly remembered, well, what does the graph of tan 30 look like? Well, tan 30 is smaller than tan 60. So that's how I remember now that this one is square root of 3 divided by 3. Cos 60 is the same as sine 30, that one's a half. Cos 30 must be the root 3 over 2. Tan 45, again another one that I just sometimes struggle to remember exactly what it is, but that one is 1. I'm picturing that isosceles right angled triangle. Cos 45 is the root 2 over 2. Sine of 60 is root 3 over 2. And tan 60 is root 3. So I hope you got 10 out of 10. So just a reminder, these are all the values that we should now have learnt. And today we are going to be using them. And I thought it made sense for this first lesson practicing using some trig values to go back to where we started trigonometry with our right angled triangles. So today we're going to try and do some right angled triangle questions, but we are not going to need our calculator for any of these. So I hope you've been able to print out my note sheet, but if you haven't, don't worry, it is just a couple of diagrams for you to do today. Now, the important thing to remember with trigonometry is if you had a question like this to do, you would still be able to get a lot of marks by using the same process as if this was a question where you had your calculator. So just remember what you can already do and then think about what angle facts you know as we move through this later on. Now also, because a lot of the angle values that you've learnt are surds, you might sometimes see surds in the question. It might not be that you need to panic about this, because sometimes the surds can cancel out and you end up with a nice whole number answer. So we're going to do a couple of easier questions and then we'll look at a slightly harder question. So these questions say use trigonometry to work out the values of x. You may not use a calculator. With this first question, we're going to do what we would always do with a trigonometry question and label the sides. Opposite the 30 degrees is opposite. The x is the hypotenuse. 8 root 3 is the adjacent. And at this stage, I don't want you to even be thinking about which angle fact rule we're going to be using. We are just going to carry on as normal. So let's think about adjacent. Let's think about hypotenuse. That is a cosine question. So we know cosine of 30 is the adjacent 8 root 3 divided by the hypotenuse, which is x. And that is set up as much as we can do so far. Now we need to think about what cosine 30 is as a value. Well, cosine 30, it should be one that you've now learnt, is root 3 divided by 2. So now on this side of the equation, I can swap out cosine 30 for its exact value. So I have got root 3 over 2 equals 8 root 3 over x. Now I'm going to do a little bit of rearranging. There might be one or two of you that can already see what value x needs to be by thinking of these as equivalent fractions. The way that I'm going to do this is multiply both sides by x. Why? Because if I'm treating this as an equation, I don't like the x on the bottom. So I end up with x times root 3 divided by 2 equals 8 root 3. Now I'm going to treat this root 3 divided by 2 as a times by root 3 and a divide by 2. So my inverse that I'm going to do next is I'm going to times both sides by 2. If I multiply both sides by 2, I will get rid of the divide by 2, so I will just have x times root 3. And 8 root 3 times 2 is 16 lots of root 3. The final step to get x by itself is divide by root 3. And if I divide both sides by root 3, well, the root 3's are going to cancel out, and I'll end up with x equals 16. So you can see, even with surds in the question, this one has come out as a nice answer of 16. Let's have a look at a question where we are finding the angle. Now, I always think these questions are a little bit more trivial in the fact that we know it's only going to be 30, 45 or 60 degrees because they're the only angles that we know for a triangle. But even with a bit of guesswork, we probably should be doing it properly. So let's set this up as we would do. Let's label some sides. I've got an opposite. I've got an adjacent. I've got a hypotenuse. So this is a tan question, and we know that tan of x must equal the opposite, 6 root 3, divided by the adjacent, which is 6. Well, 6 root 3 divided by 6 is just root 3. So we just need to ask ourselves, tan of what angle is root 3? That angle is 60 degrees. Let's look at a final question where we've got to do a little bit more, and there's a question similar to this in one of the questions that you're going to do for me today. It says, work out the area of the following shape. Well, we know this shape is a triangle, and we also know that if I knew the triangle's height, I could do base times height divided by 2. There might be one or two of you thinking, oh, there's that other formula, half AB sine C. But in order to do that, I would need to know both of these sides, either side of the 60 degrees. So I'm going to work out the size of side X and then use base times height divided by 2. So again, let's label up the triangle, see what we know. 60, well, opposite the 60 is the 4 root 3. And the x is the adjacent. So this to me looks like another tan question, opposite over adjacent. So I know that tan of 60 equals opposite 4 root 3 over adjacent x. What do we know about tan 60? That's using our facts. We know that tan 60 is root 3. and that has to equal 4 root 3 divided by something. Now, I could do a lot of rearranging here, but I hope you would realise what value x needs to be for this side to be the same as root 3. We need the 4 to disappear, so it needs to be 4 divided by 4. So x must equal 4 centimetres. So sometimes, yes, you might need to rearrange it, and it would be the sensible thing to do. Other times, you might just be able to see what that value of x is. So I now know that this is 4 centimetres. How do I find the area of my triangle? It's base times height. Don't forget to divide it by 2. So it is 4 lots of root 3 times 4 divided by 2. Well, 4 root 3 times 4 is 16 root 3. But I still need to divide it by 2. And 16 lots of root 3 divided by 2 is 8 root 3. And it wouldn't be units squared, it would be centimetres squared. So, lots of opportunities for you to show me that you have learnt your different trig values, and also a few opportunities today to revisit manipulating some surds. So if you'd like to go back to my instruction sheet, you'll find a link to the PowerPoint. There are, I believe, 10 questions for you to try. If you want to try the more challenging questions, they are towards the end. As always, there are the answers for you to check against. So if you get something wrong and you're not sure why, please ask in the Ask the Teacher channel. And also remember to do that if you're having a problem with anything else.